Hello, we'll start example 5 using the z-test for a mean and try it this way so that hopefully I can recognize my videos a little bit better to upload them to YouTube a little easier. Okay, so here we're still in chapter 8 section 2. We're just doing more applications of the z-test for mu, and like we mentioned, we're looking at example 8-5, and this is coming off of page 430. Alright, so let me go ahead and recite the problem. It's dealing with the cost of rehabilitation. It says the Medical Rehabilitation Education Foundation reports that the average cost of rehabilitation for stroke victims is $24,672. To see if the average cost of rehabilitation is different at a particular hospital, a researcher selects a random sample of 35 stroke victims at the hospital and finds the average cost of their rehabilitation is $26,343. The standard deviation of the population is $3,251. At alpha equals 0.01, can it be concluded that the average cost of stroke rehabilitation at this particular hospital is different from $24,672? Okay, so let's go ahead and run through the steps of performing our hypothesis test. So first of all, we're going to state the hypotheses. I will state H subscript 0, the null hypothesis. It says mu is equal to 24,672. Okay. So basically, the meaning behind this, or the implication of this, is that if we don't detect any difference, if this, what looks like an apparent difference, if it's not statistically significant, then what are we going to be able to conclude? Nothing. And so what will we be left with? Well, we'll be able to say about this particular hospital that nothing new, nothing distinct, nothing new and different. What's the average rehabilitation cost at this particular hospital? The same as it is at every hospital. $24,672 to be precise. And so what we're looking at here is we're just postulating perhaps it's different here. We don't have an idea. Is it greater? Is it lesser? We're just going to say it's different than $24,672. And this is what we're suspecting, right? We're suspecting that it's different here at this particular hospital than the average for the nation. And so this is our claim. All right, remember, it's not always essential to identify the claim. It just helps us at the end, and it kind of helps us think about the whole problem altogether. So now, step 2. We're going to go ahead and find the critical values. And in order to do this, I always like to sketch the distribution, right? Okay, so since we're saying that it's not equals, right? This is going to be a two-tailed test. And we have a total alpha equal to 0.01. And so here is another instance where, similar to a confidence interval, we're going to divide alpha by 2. And so alpha over 2 on this side, the area underneath the right tail is 0.005, okay? And then alpha over 2 on the left tail. So its area underneath the left tail is 0.005 as well. So we'll go ahead and pause to look up these critical Z values. And remember that these are ones that we run into over and over and over again. So after a little while, we probably don't have to look them up anymore. So we come up with negative 2.58 and positive 2.58, since, again, this is a two-tailed test. The next step, 3, is to compute the test statistic. This is the Z-test, so we're computing a Z-score. It's computed the same way that we remember computing Z-scores, so it is like this. Z is equal to chi-bar minus mu, all divided by sigma divided by the square root of n. And we'll go ahead and substitute in what we have here. The average for the sample that we looked at was 26,343. Our average here for our hypothesized population parameters, 24,672. Okay, we're going to be dividing all of that by what they told us for sigma. Okay, so sigma, they said, was 3,251, and then that is divided by the square root of, I don't know, I haven't used red yet, so the sample size was 35. So we'll go ahead and substitute all of that in on the calculator and let it do its thing. And presto chango. No, I mean, just kidding. After doing this calculation, we get 3.04 for our Z value. All right. So we'll go back up to the picture here. Oh, you can see it here. So 3.04. Remember, this is not 100% accurate. This is just a sketch. Zero's in the middle. There's 2.58 on this side. There's negative 2.58 on the left side. Whereas 3.04, I don't know. But I don't know 100% accurate, but I do know that it's past 2.58. And so we are in the rejection region. Remember, this range of X values from here and above and from here and below is the rejection region itself. Those are the Z statistic values. If we're in that range, then we have to reject the null hypothesis. Okay. There's still a chance that we might be getting it wrong, but that's going to be our decision. So our decision in step 4 is we are rejecting the null hypothesis. Reject H subscript 0. All right, so we have rejected the null hypothesis, so that leads us to the last step. Step 5 is we're going to summarize the results. And we'll say, always in terms of the evidence, right? So we'll say there's enough evidence, and essentially at this point in time we want to think back to what was our claim. The claim was that things are different at this particular hospital. The rehabilitation cost at this particular hospital is different from the national average, which I think they gave us 24,672. So there's enough evidence. This is the part I always hate because I write everything out. There's enough evidence to suggest a statistical difference or significant difference or just a difference between the average cost of rehabilitation at this hospital and the national average of $24,672. So that concludes this example, and we'll move on in the next lecture to the p-value method for hypothesis testing.